This homework assistance video is designed to be used with Chapter 1, Lesson 6, Solving Proportional Relationships for our mild and hot problems that we have assigned to us. I want to go through a couple of them because there's a couple different strategies we talked about in class, and I want to make sure that we're looking for those strategies and that we have a method even when some of them look different than what we would expect. So let me grab my pen tool here and we'll get started. The first one just says solve each proportion, and it tells you that you can go back to examples 1 and 2 in the book. And when we talk about proportions, the first thing we want to remember is that proportion, by definition, is just two equal ratios. So we have 1.5 is to 6 as 10 is to our variable p, and p is what we don't know. That's what we're looking for. So we have to find a way to determine p, assuming that this relationship is going to hold. So what they taught us in the book is they taught us something called cross products. And cross products imply that if we multiply across our proportion from the denominator on one side to the numerator on the other, it will always be equal to multiplying from the numerator on one side to the denominator on the other. So if we try that, here's what it looks like. Cross products would say that 1.5 multiplied by p would have to have the same value as 6 multiplied by 10. They're products because product is an answer to a multiplication problem, and they're cross products because we literally went across the proportion. So now this tells us that we have 1.5 multiplied by p should have the same value as 6 times 10, which is 60. Now we have to go back to elementary school and think about fact families. In elementary school, we learned that fact families work like this. If 2 times 3 has a value of 6, then we also know that if we start with a product, we could say 6 divided by 3 is equal to 2, or 6 divided by 2 is equal to 3. So we can use the product and what we call our multiplicand and multiplier to find the missing number. So take this idea and apply it over here. If 1.5 times p is equal to 60, then we know that 60 divided by our 1.5 is going to equal p. So this is what we're looking for. Now it doesn't feel very natural, and so we're going to talk about another way we can do it. But if we divide that out, we end up with p equals 40. And I'm okay if you guys use calculators with this. If you can do it mental math, that's preferred. But if you can't, you can divide it longhand or use a calculator. So what we end up with is p equals 40. And again, to review, cross products, 1.5 times p has to equal 6 times 10. So 1.5p equals 60, and then we just divide to get our value of p back, which ends up being 40. Okay? Now, let's go ahead and erase this real quick, and let's take a look at a couple more. If we look at this problem again, some students notice this right away, and this is a more natural way for some students to do this problem. I encouraged you in class to look for what we call horizontal or vertical scale factors. How could we get from 1.5 to 10 or 1.5 to 6? And what a lot of students notice is that if we multiply down, if we double 1.5, we get 3. And if we double 3, we get 6. So if we do 1.5 times 4, we get 6. So if 6 is 4 times bigger than 1.5, then it would make logical sense that the value of p must be 4 times bigger than 10. Well, 10 times 4 puts our value of p at 40. So it's the same exact thing we did before. It's the same exact answer. It's just our method's a little bit different. Take a look at number 2. If I look at number 2, I see that 44 is to p as 11 is to 5. Now from 11 to 5, I don't see a natural scale factor. I can't double 5 or triple 5. But when I look from right to left, I do notice something. When I look right to left, I notice that if I multiply 11 times 4 again, and it's not always 4, that's just a coincidence. If I do 11 times 4, I get 44. So then it makes sense that I would have to also do 5 times 4, take this 5 4 times bigger, and that'll give me my value of p. 5 times 4 is 20, so that puts my value of p at 20. Now you might be asking, yeah, but what happens if I do those fancy cross products? Well, here's what we end up with. We would say that P times 11 has to equal the same value as 44 times 5, my other cross product. Now let's do some mental math together. P times 11 equals 44 times 5. Now I didn't learn my 45 times tables in elementary school, and neither did you guys. So we can split this up. I know that 4 times 5 is 20. So 40 times 5 must be 200. So I can take this 44 times 5, and we've worked on this in class, and I can split it and say, well, that's 40 and 4. Now 40 times 5 is 200. 5 times 4 is 20. So that means together that combines to give us 220. And again, if you don't understand the quick mental math, you can use calculators. You guys have them on your phones, your iPads, everything. So go ahead and use a calculator if you'd like to. Now what that leaves us with is, like we said in problem 1, if P times 11 is 220, then 220 divided by 11 must equal P. We just use fact family from elementary school. Well, 11 goes into 22 twice, gives us 0, so 20 is our final answer. And if you look, it matches what we did using the scale factor idea. So we're good to go. Okay? Now let's take a second. If you're clear on this and you want to just continue on your homework, that's fine. I'm going to do a couple of the narratives just to take a look at them. Narratives, remember, are a fancy way of saying story problems. Number 4 says, assume the situations are proportional. Write and solve by using a proportion. So let's try it. If we have to write it, let's see what we get. It says Everardo paid $1.12 for a dozen eggs. So $1.12 per dozen. And right above a dozen, I'm just going to write 12. At his local grocery store. Determine the cost of 3 eggs. So the first thing we have to do is we have to write our proportion. So here's what it's going to look like. The first piece of information they gave us was $1.12, or I'm sorry, yes, $1.12 for 12. So I'm going to say $1.12 is to 12 eggs as, now this is where we have to be careful. In our first ratio, we put money on top and eggs on the bottom. So in our second ratio, it's really important that we put dollars on top and eggs on the bottom. And how many eggs go on the bottom? Well, it's going to be 3. We're going to put a 3 down here. Okay? Now, again, I'm going to look at my scale factors. If you want to do cross products with a calculator, that's fine. But I noticed something right away. I notice if I go from 12 to 3, I can just divide by 4. 12 divided by 4 gives me 3. So then it makes logical sense that I could take $1.12 and divide it by 4 and get my answer. So over here on the side, I'm going to take $1.12 and I'm going to divide it by 4. I'm going to move my decimal up. 4 goes into 11 2 times, which gives me 8. I subtract, I get 3. I bring down my 2, and 4 times 8 is 32, which gives me a remainder of 0, which is what we want. So I found that 3 eggs is going to cost 28 cents. So we're just going to put 28 cents for 3 eggs. Now remember, our 3 S's for successes: set up, solve, make sure you state your answer by the time you're done. If you state your answer, you're going to be in really good shape. Okay? Again, if you're clear now, you can quit watching. If you want to see one more, I've got one more I'm going to do for you guys, and we'll call it a day. Alright? I want to show you number 6. In the directions, it says assume the situations are proportional, and then use the unit rate to write an equation and solve. Now this goes back a couple sections. Remember, a unit rate is when we take a rate and simplify it down to each, per, or every time. It's when there's a 1 in that denominator, that bottom number. So let's see what we get. It says a car can travel 476 miles on 14 gallons. So they just introduced a rate to us. So I'm going to come over here and I'm going to write that down. We know we can go 476 miles per each, every, on 14 gallons. Now go back to the directions. It says to use a what? A unit rate. So before I even read any more into this problem, I'm going to grab a calculator and I'm going to divide this out. 476 miles to 14 gallons is going to, when you divide it, turn out to be 34 miles per 1 gallon. Okay? Now it's a unit rate because this one had 14 gallons. We don't care about 14 gallons. We care about having 1 single gallon is what we want. So 34 miles to 1 gallon. Now the question is, how many gallons of gas does the car need to travel 578 miles? Well, we could set up a proportion like we did in 1 and 2, but it asks us specifically to use an equation. Okay? And it says to use the distance, D, and the gallons, G. So it's a lot of stuff to pull out of this narrative. So I'm going to say this. My distance, D, that I can travel, is going to be equal to the 34 miles I can go times every single gallon of gas I have. So 1 gallon, 34 miles. 2 gallons times 34 is 68 miles. 3 gallons times 34, and so on and so on. So now let's see what we have. The question is, how much do I need for 578 miles? Well, since miles is a distance, I know that this is the value for D. So here's what I'm going to do. I'm going to come in here now and I'm going to say, well, that means 578 must equal, I put my miles in for my distance, I go 34 miles per gallon. Okay? So 34 miles times my gallons of gas has to give me 578 miles total. Well, now again, we're back to fact families from elementary school. If 34 times G is 578, well, then that means that 578 divided by 34 must give me my gallons. Another way to think about it, we're taking 578 miles and splitting them up into groups of 34 miles at a time. So 578 miles divided by 34 miles at a time will give me the number of gallons I need. And again, if you go to a calculator and you divide that out, you're going to find that it's going to take 17 gallons of gas. Okay? Well, we're going to end here. If need be, I can post another video if you have other questions, but go ahead and go through the rest of either your hot or your mild problems, and we'll answer any questions that you have in class. Good luck.